Welcome, and thank you for joining us at this virtual distinguished open lecture by Dr. Nicholas Fuller, who is the Director of Hybrid Cloud Services at IBM Watson Research Center in New York, USA. Dr. Fuller's presentation is on accelerating the transformation of traditional enterprises with artificial intelligence. I am Professor Neela Badri, and I'm the chair of the Open Lectures Committee, Office of the Campus Principal, right here at the University of the West Indies, St. Augustine, Trinidad and Tobago. I would like to acknowledge the presence online of the panel, Professor Brian Copeland, Pro-Vice Chancellor and Campus Principal of UWI St. Augustine, our distinguished feature speaker, Dr. Nicholas Fuller, Director of IBM Watson Center in New York, Dr. Phaedra Mohammed, Lecturer in Computer Science, Department of Computer and Information Technology, Faculty of Science and Technology, Mr. Niall Farnan, Head of Optometry Unit, Department of Clinical Surgical Sciences, Faculty of Medical Sciences, and a member of the Open Lecture Committee. Also acknowledge the presence of members of management of UWI, staff and students of UWI, colleagues, friends, and family of Dr. Fuller, the business sector. I know a number of companies have registered throughout the Caribbean, our specially invited guests, the public, and members of the media. Artificial intelligence has been creating quite a buzz in the industry, and it has the ability to solve problems by a machine that would usually be done by human beings. Hence, these machines are usually incorporated with human-like intelligence to perform tasks that we would do. And AI has found its way into our daily lives, and it has become so general that we do not even realize we use it all the time in healthcare, in robotics, in marketing, in business analytics, and many more. Some familiar applications of AI, for instance, in Google's search engine for search terms, the finance sector of JP Morgan, which uses machine learning algorithms and visual recognition software to analyze legal documents. Facebook, for instance, uses AI for face verifications, and Twitter is being used to identify hate speech and terroristic languages in tweets. It makes use of machine learning, deep learning, and natural language processing to filter out offensive content. And IBM has developed an AI software specifically for Medicare use. In 2016, AI technology was able to cross-reference actually 20 million oncology records to diagnose a rare leukemia condition in a patient. It is of interest that the upcoming Tokyo Summer Olympics will be using robots to welcome participants. So this afternoon presentation is of interest as Dr. Fuller speaks about his input into a number of AI-based innovations and application and patents to differentiate IBM's hybrid multi-cloud platform. To introduce Dr. Fuller and to bring opening remarks on behalf of the University of the West Indies St. Augustine campus, I would like to invite Professor Brian Copeland, Vice Chancellor and Campus Principal. Professor Copeland.
Thank you, Neela. And I will say good afternoon to you as Chair of the Open Lecture Committee of the St. Augustine campus. Good afternoon or good evening as well to our distinguished feature speaker, Dr. Nicholas C.M. Fuller, members of the Open Lecture Committee, Dr. Phaedra Mohammed, Lecturer in Computer Science in the Department of Computer and Information Technology, and Chair of the Question and Answer segment, faculty, staff, students, ladies and gentlemen all. Good evening again. On behalf of the St. Augustine campus of the University of the West Indies, I am pleased to welcome you to this evening's distinguished open lecture. Now, these open lectures are not simply academic affairs. They are a mechanism to bring prominent faculty and industry researchers to our campus, and in this virtual world, to anyone, anywhere in the world with an interest in the topic and a keenness to be inspired. I'm truly looking forward to this evening's lecture on artificial intelligence, or AI as it's called. It is one that excites my scientific curiosity as a control engineer, first piqued by the work here at St. Augustine by one Dr. Albert Kong way back in the mid-90s. It also brings back wonderful memories of how the concept has influenced science fiction over the years, from HAL in the 1968 movie 2001, A Space Odyssey. You can tell from this that I'm a sci-fi buff. What, or maybe you could say who, many consider to be the most famous famous computer in cinema history, to the emergency medical hologram called the Doctor in the Star Trek Voyager series that evolved, sometimes spontaneously, sometimes autonomously, to a sentient being with a realistic personality, a digital life form indistinguishable from a human entity. Exciting, but to many, a bit scary. World famous mathematician and hero codebreaker of World War II, Alan Turing, addressed the problem of AI in a 1950 article entitled Computing Machinery and Intelligence. Turing began his essay with the words, I quote, "I propose to consider the question," he quotes, "can machines think?" he unquotes, and proceeded to argue that they could. AI seeks to replicate or simulate human intelligence in machines. It is defined as a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. In the 70 plus years since Turing wrote that paper, AI is now at the core of computing, not simply a feature. Systems now have the ability to learn through data, statistics, trial and error, to optimize processes and innovate quickly. Advancements in machine learning mean that computers can, like their sci-fi models, develop human-like learning capabilities to fast-track transformational solutions to major issues. In this global pandemic, we in academia have been particularly grateful for technology, allowing us to pivot, if not without pain, to distance learning, remote work, virtual graduations, and webinars like this one. This is our new normal. AI, as I said before, is no longer science fiction. It is part of our everyday lives. But what does this paradigm shift mean? If AI enables computers and machines to mimic the perception, learning, and problem solving and decision-making capabilities of the human mind, should we, mere humans, be afraid? Our speaker this evening is a gentleman who will help us get our mind around this ongoing debate. He traces his origins from Barataria. I almost said Barataria. It's actually supposed to be his correct pronunciation. In Trinidad, but now lives a long way from what was once his home. His reach is global, and he's also synonymous with IBM Watson. Nick is no stranger to the UE, with a relationship that began back in 2008, I believe, when one of our Department of Electrical and Computer Engineering students was chosen as an intern to join the IBM TJ Watson Research Headquarters in Yorktown Heights, New York. I'm sure that Dr. Malalu and Dr. Puran Singh are happy to see him here. Dr. Nicholas Fuller is currently director of the Hybrid Cloud Services organization at IBM Research. In this role, he leads a global team of over 100 research professionals and is responsible for providing AI-based innovation to differentiate IBM's hybrid cloud platform. These innovations span multiple domains in the journey of mission-critical applications to hybrid multi-cloud environments, namely application modernization, extensions to Red Hat's OpenShift platform for observability and edge infrastructure, security and compliance, and incident management. In his 18 plus years at IBM Research, Nick has held multiple technical leadership and client-facing roles, working in partnership with various IBM product units and clients, not the least of which includes various IBM server and game processors such as Xbox, PlayStation 3, and Nintendo Wii. Nick is an IBM master inventor, holding more than 70 patents, has co-authored 75 technical publications, and regularly provides commentary on AI and hybrid cloud integration for outlets such as IEEE Spectrum, Computer Weekly, and Caribbean Media on the Caribbean Communications Network Television 6, Jamaica Gleaner. He obtained his Bachelor of Science in Physics and Math in 1997 from Morehouse College and his PhD in Applied Physics in 2002 from Columbia. Ladies and gentlemen, I am so delighted to welcome back Dr. Nicholas Fuller, Director of Hybrid Cloud Services, IBM TJ Watson Research Center, New York, who will speak to us on the topic, Focus on Artificial Intelligence, Paradigm of Computing. I thank you.
Thank you for that warm, generous introduction, Professor Copeland and Professor Badri. I'd like to really thank the committee of the Open Lecture Series at University of the West Indies for inviting me to participate and deliver this distinguished lecture. My heart, thoughts, and prayers as well go out to the people of the globe, all of us struggling with this pandemic at various phases, and certainly in a peak phase in the region, and of course, my country of origin, Trinidad and Tobago. Together, we will all make it through this. And as Professor Copeland said, thankfully, we have significant advancement in technology that can help us continue to propel forward and indeed solve some of these problems. So we heard a very good introduction by both Professors Badri and Copeland regarding AI and where AI has been used to date. Interestingly, when you look at AI as it relates to both traditional enterprises, non-traditional enterprises, consumers, there's a dominance of its use at an analytic level, at a business process level. The whole notion of taking AI and applying it to software, to the application stack on which mission critical applications run to transform an enterprise, while there has been work in this space, it's one that we have amplified over the past couple of years. And this is where I will spend significant attention tonight with you. So a quick outline for what I will share over the next 45 minutes or so. I want to touch on briefly two technologies. None of them are surprises to anyone here, namely cloud technologies, what I call here Cloud 101, and AI, a taxonomy for AI, characteristics, and the success we've seen with AI in human language. I'll introduce something subsequently known as AI for Code, and perhaps many of you have seen Project Codenet. I'll get into what Project Codenet is about, and then how AI for Code use cases of AI for Code apply to enterprise transformation, namely modernizing applications, security, compliance, and IT operations. So let's get into it. Cloud is no surprise to anyone on this call. Irrespective of your role, you witnessed the introduction of cloud driven heavily by Amazon in early 2006. Famous article 6 years subsequent to that in the New York Times, highlighting how much cloud computing had reshaped IT as a whole. And Microsoft isn't mentioned here, but obviously they're the second most dominant player from a public cloud standpoint. And then Google with IBM making up that sort of top four. Within recent time, we have shifted and amplified our focus on how public cloud can be a key destination for financial firms, for financial services sector, namely banking, insurance, and the like. When you look at this landscape of cloud, though, as you see from this chart, what really dominates the spectrum is a proliferation of so-called SaaS enterprises, software as a service. Okay, so in the bottom right, for example, apps that many of us use quite frequently. We're using Zoom right now. Zoom, as I understand it, hosts 300 million, just wrap your head around that, sessions on a daily basis. And Zoom is just one such application. WebEx is another, Skype, of course, is another, and so on and so forth. Netflix, Uber, Slack, Veryjet, the Uber of the skies. These are apps that have really disrupted their relevant industries and so-called born on the cloud apps. These apps didn't have, the companies that you see here in front of you never had their own infrastructure, so to speak, always running on some cloud provider. In terms of the bottom right, heavily Amazon, Veryjet runs on IBM's cloud. Additionally, even if they weren't born on the cloud, various CRM, customer relationship management, and ERP, enterprise resource planning applications, like the four you see in the top right, namely Salesforce, the Weather Channel, SAP, Workday, which is a human resources application, are also SaaS type applications. So these are SaaS enterprises, and this is largely what we have seen in cloud to date. Now, it may surprise you that traditional enterprises, only 20% of their workloads are on cloud today. And this is data from a variety of analyst firms like Gartner, IDC, Forrester, and the like. And so what that means is there's an opportunity for these enterprises. Now you have to ask yourself the question, why? So partly driven by maturity, partly driven by regulations and a host of other issues, which I'll get into. For the most part, traditional enterprises in the financial sector, in the retail sector, in the communication sector, telecommunications world over have not yet really capitalized on the promise of cloud. And when you step back and think about what cloud is, it's a utility. It's no different in terms of what we subscribe to from some central provider like electricity, like water. And no one, rents a home, buys a home and builds a power plant, right? Or sets up a desalination plant and the like. Now, those technologies, of course, are very advanced. Cloud has gotten to that place as well. So there's a huge influx, so to speak, a huge opportunity for traditional enterprises and their hundreds to thousands of apps to leverage the benefits of cloud. And those benefits I'll touch on in a second. I just also want to highlight some representative examples of companies that have started to leap forward in this direction. So from an airline perspective, American Airlines, JAL, Japan Airlines, Bank of America, the large French bank, BNP Paribas, have all begun to take advantage of moving their workloads to cloud, and in the case of these four, to IBM. So let's demystify a bit what cloud means, because in the beginning, with virtualization technology, that really meant virtual machines. But there are three underlying technologies that really make it a huge impetus for traditional enterprises to want to take advantage of cloud. The first of these is containers. Now, a virtual machine is just like what it sounds. It's a virtualized server, and depicted here schematically, architecturally on the left. Containers, which is one second, going back to virtual machines, it's that virtualization, partitioning of compute, network, and storage. Containers is a different type of virtualization. It essentially partitions the operating system. And what that does is you see some of the properties here shown. Whereas with virtual machines, you update in place, you can SSH into a virtual machine to make changes. They're very heavy, right? They're not very portable, and they're very tightly coupled to application design. With containers, they are very lightweight, very portable, and they encourage immutability, meaning updates are only done by replacement, as opposed to what you typically do for a virtual machine, namely SSHing into a virtual machine. Key consideration, right? There are three technologies I'll outline here. Containers is one. The next one is the whole notion of microservices. So what's this? Historically, and this again underlies how traditional enterprises with their own infrastructure have functioned, have built applications in a monolithic fashion. In fact, if you interview many traditional enterprises and you go through their IT departments, documentation for apps, some of it exists, some of it doesn't. The people who built those apps in the beginning may have transferred to a different part of the organization or have gone completely. And so it's very difficult actually to wrap their heads around that application and exactly what it contains, its topology and the like. So monolithic applications, as you see here, all functionality in a single process, centralized data tier. Okay, very difficult in terms of updates. Updates are done, in a waterfall fashion. Whereas when you have microservices, the application, much like it sounds, is broken up into a finer grain type structure with decoupled services that are independent, have their own independent life cycle, and communicate only via APIs, decentralized data. So this is the second key piece in terms of modern cloud technology. The third one I'd like to touch on, also very familiar to many of you, I'm sure, is the whole notion of smashing together development and operations, is what is known as DevOps. And today we actually speak of DevSecOps, which means you introduce security gates in that overall DevOps process. And what this essentially means is it highlights the whole transformation of continuous iteration, the whole notion of continuous iteration and continuous development, abbreviated typically as CI/CD. So this really underscores the whole transformation, going from a waterfall approach to an approach that is continuous, with cycles on 2 to 3 weeks or so typically. When you smash these three technologies together, containers, microservices, DevOps, DevSecOps, this really underpins the foundation of modern cloud. Container technologies today are largely, modern container technologies today are largely based on what is known as Kubernetes, right? And this is the other point in terms of open technologies helping to grow ecosystems. Every major hyperscaler, every major cloud provider has a Kubernetes service. There are multiple Kubernetes platforms. OpenShift, Red Hat, which IBM acquired a few years back, is an example of a container platform. And so what this does when you bring all of three of these together from a traditional enterprise point of view, it's not just technology, it's technology that benefits business. Why? Few reasons. Technical debt is a huge part of maintaining your own application stack. You have dated OSs, dated middleware, right? And some of it might not even be supported by the vendors who manufactured those various OSs and middleware. That's one. Two, the whole notion of agility. This is exactly what you get with DevOps, microservices, containers. You can update an app every 2 to 3 weeks. You can release a new feature every 2 to 3 weeks. And this is precisely what many of these modern architectures, these so-called born on the cloud SaaS enterprises do. That's not available. That approach is not available to a traditional enterprise, even if they're running on virtual machines on their own premise, even if they're running on virtual machines on cloud largely, because they have to subscribe to a waterfall approach. And last but not least, providers, cloud providers, of course, they have a variety of services. And these services, whether they be AI services, data services, storage services, what have you, they are benefits that you can now integrate in a microservices architecture to evolve your application. And why is that important? Well, from a line of business point of view, you have multiple apps reaching out to your consumers who subscribe to those apps. And so based on what market demand is telling you, you can quickly respond to market needs by integrating new services from the provider. A very different approach if that app is running on your premise and you have to continue and maintain a waterfall style of dropping applications, a new version of an application every few weeks, every few months, as opposed to every 2 to 3 weeks. Very different. So software technology, software development, and the overall software development lifecycle has really transformed with these three technologies that I just highlighted here: DevOps, microservices, and containers. And you'll see this play itself through as I discuss how AI can actually help traditional enterprises get to this point. So let's talk a little bit more about AI. You heard very good examples before, and we like to think about it in this taxonomy that you see in front of you. Quote unquote, narrow, broad, and general. Well, what's narrow? Narrow AI, it's narrow in the sense that, okay, yes, it's based on deep learning, but largely subscribes to the requirement of having large amounts of labeled data that allows you to train that data and then test that data, inference, to get various signals, okay? And of course, acquiring superhuman accuracy in the process. And that's really where we began. The evolution of that, and largely where we are today, is in this so-called notion of broader AI, where it's multimodal, right? It's no longer simply just text. There's images, there's videos, what have you. There's learning from less data. There's unsupervised models, okay? And you'll see some examples of unsupervised models in a few as I go through the rest of this. There's the ability to reason as well, quite critical, and provide explainability. If I'm a practitioner doing XYZ, whatever that might be, and I'm subscribing to some sort of AI system, I would like to know that I can benefit from recommendations, yes, but I would also like to know why. And largely, we're seeing the emergence of this, and I'll touch on some of that as well. And general AI, neurosymbolic AI, hot area of research. Not much of that has made its way by way of applications, but certainly a hot area of research in various academic institutions and industrial labs as well. So let's peel this back a bit. Narrow, broader AI has had tremendous success. You heard about search engine optimization using Google search, for example, other examples given by Professors Badri and Copeland in the introduction. I show a few examples here, which I thought would be quite relevant, both from a regional point of view and given the nature of the pandemic. So three AI services shown here on the left. From our Watson suite, our conversation service, our document search service, and our AI model management service. All AI models have to be managed, and that lifecycle management is critical in using that AI system. And with CVS, actually, this was a feature of our Think conference last week, significantly transformed how they have been able over the past few months to handle the influx of calls coming in from people seeking vaccinations, and a wealth of different questions. Very different from, doing a database lookup and getting some sort of song or what have you, right? Quite a complicated problem. And the agent they were able to deploy here, working with our teams, have not only reduced the load, you see the volume of calls handled in that 4-month period by CBS. Another good one is in a bank, Bradesco, major bank in Brazil. Huge issues prior to implementing conversational assistance to handle customer-related calls, 10-minute waits. None of us who in that sort of fast-paced setting would subscribe to that and be acceptable. That would be acceptable to us. And so with this capability, they were able to significantly reduce that wait time from 10 minutes to seconds. The thing that I want to impress upon you here is this is human language. Okay, there's a huge scale that you see here in front of you. And it's typically the entry point as well for enterprise transformation at the business process level. So whether that's customer relations, whether that's supply chain automation, things that people in traditional enterprises and enterprises as a whole think about, this has typically been that entry point. Predictive analytics, I don't cover that here, but there are many companies locally exploring that as well in the banking sector and the like. That said, this gets you so far. It certainly has benefits, as you see in front of you. But when it comes to unlocking cloud, in terms of what I described before, eliminating technical debt, enabling agility, enabling lines of business to quickly integrate new services from a provider, from multiple providers to grow their business, this doesn't necessarily help with that. That's still very manually driven and so on. So the notion of how do you take AI and apply AI to enabling traditional enterprises in the application stack, infusing AI into the application stack is what I will touch on now, and is what dawned on us. This is our inspiration for what we're calling AI for Code. Code is the language of machines. So while we have harnessed the power of AI for human language, for a range of human languages, for a range of machine language, Python, Java, you name it, all languages, COBOL, PL1, etc. Can we enable AI to transform applications for traditional enterprises so that they can run on modern hybrid cloud architectures and see those benefits, keep them secure, keep them compliant, keep them available? So this is the mission we started on, and there's been elements of this, just to be clear, right, across the industry in various levels, particularly in the incident management space. Last week, we launched what is now known as Project Codenet. Okay, Project Codenet, similar to ImageNet. ImageNet revolutionized vision, computer vision. We believe that Codenet will do the same thing in applying AI for code in terms of helping you with modernized applications, security, compliance, availability. And just some of the characteristics of Codenet in terms of the numbers, this data set, 14 million code samples, 4,000 plus code problems covering 55 programming languages and 500 million lines of code. The public Git is shown here and accessible for anyone. And the idea is to pursue breakthroughs in language translation, search, retrieval, code similarity, some of the very things we've done already on the human language side. So that's the impetus for this. And we have already seen strong pickup from other industrial labs. We've seen strong pickup from companies. We've seen strong pickup as well from various academic institutions to enable this to be a hot area of research and grow the area, much like ImageNet did for computer vision. So getting back to the use cases now, right? I want to touch on so-called AI for code use cases to help traditional enterprises, again, unlock the value of cloud. So just the baseline once more. So if I have, as a traditional enterprise, hundreds of apps, thousands of apps, and I subscribe to what I just said, okay, I believe that, yes, I will eliminate technical debt. Yet I will have faster agility, or I'll enable agile process. Yes, I will also have the benefit of unlocking the value of cloud to grow my business and significantly respond in a faster way to market demands. Then I need to figure out, okay, how do I get workloads there and how do I manage them? So the whole notion of advising, moving, building, and manage is sort of the taxonomy we apply to that journey of traditional enterprises to cloud. And in each of these domains, you see, well, I have to modernize, I have to improve the developer experience, I have to enable security, compliance, and availability. And we see when AI is applied, we can reduce the time to refactor apps. We'll touch on that. I can improve the developer productivity. I can reduce threat management. I can get threat management intelligence. I can enable compliance from a risk-based point of view. I can reduce the time to recover from outages and the like. So in the absence of AI, these are all very difficult tasks, and I'll show you why. And not only will I show you why, but when I do, you will understand why many enterprises have been so slow to even move a significant fraction of their workloads to cloud. So let's jump here. Since we've launched this going on a year or so, like I said, we've done this for a few years back. We've received some good coverage in the press, just highlighting a few of these here from IEEE Spectrum, Computer Weekly, nice tweet last week from ACM, Association of Computing Machinery, and VentureBeat. So we are really gung-ho on this approach and looking forward to the outcomes. So let's get into it. Let's start with modernization. That's really where it begins. If I have hundreds to thousands of apps, as is the case for many traditional enterprises, it's absolutely mind-boggling and a nightmare to even know where to begin. Which ones should I move? Which ones should I retain? Which ones should I retire? Okay, and this is exactly the exercise that many of these traditional enterprise, whether it's banking, whether it's telecom, transportation, have to undergo. This is what they have to think through. And just to motivate the discussion even more, right, I show an example here in the press from last year when the pandemic was really impacting North America, the US significantly. And of course, unemployment grew. Many people were filing for their unemployment checks and the like, and the system could not scale. The system was built. These are running on legacy systems, legacy software. So there are two issues here. Not only it's from an application point of view, but then the management of that infrastructure. This infrastructure isn't built to have elasticity, much in the way that the cloud is built to have elasticity. Again, coming back to Zoom, 300 million sessions a day, right? And that presumably goes through some dip over the weekend and then ramps right back up come Monday morning in Asia and sweeping its way across to the West Coast of the US. And that level of elasticity is what you get from cloud. And so this motivated the need from a federal point of view, government point of view in the US to look at aging tech. How can they modernize these applications so that this type of issue goes away if there's another surge for whatever reason? And COVID is one example. Clearly, this can apply to other cases as well. And so when you begin to piece this back, right, as I said, you know, the whole notion of figuring out how to modernize an application that has been running where you don't have documentation, where the people have moved on and so on, you know, this is data collected from several clients. It can take 3 to 18 months to just do planning and discovery. Buy an app, okay, one app at a time, just to be clear, okay? And once that is clear, okay, great, I have that figured out. Another 9 to 12 months to transform, and that's an average. It can be longer than that. I'll show you an example where it is longer, where it was longer. And so multiply that by tens, hundreds, thousands of apps. It's something you will not do, right? As a CIO, as a CTO, why would you? Look at the time scale that you have to look at in order to figure out how to reasonably get workloads modernized. Now, if you're a smaller enterprise, maybe that's okay. Maybe you have a few mission critical apps and that's where you start. But the larger the enterprise, the more complex the situation becomes. And so the approach typically taken here is what is known as, in this planning and discovery phase, to figure out what you move, a 6R analysis, right? Where there are 6 R's that apply. And here you see a depiction of ultimately what you might do. You may rationalize and decommission some of these. You might replace some of these with an as-a-service solution. For example, if you had an HR system that you built from the ground, you may replace it with Workday, which I showed before, right? And then finally, there's the whole what I modernize and migrate, okay? And there are various ways to do that. You can rehost, so-called lift and shift. So essentially you take the VMs, running from your premise, and you move those VMs to some cloud provider or multiple cloud providers, as is typically the case for traditional enterprises. You might re-platform. What does that mean? Maybe you want to bite the bullet and take those VMs running presumably on some VMware environment and re-platform them, to a container environment. Re-platform them to Kubernetes, right? The dominant container management platform today. Okay. Or you may go further, the next step, right? Refactor, re-architect. Knowing the benefits of microservices, you may bite the bullet and you see what fraction of workloads fall into that category and refactor, re-architect. And then, of course, there's some you might retain for a variety of reasons. They're driven by every enterprise unique needs. And so this is exactly what is done. This is the time that is spent by CIOs and their teams looking at this complex equation as they figure out what to move to cloud. And in the next chart, I'll touch on the first part of this, right? Namely, rehost, lift and shift. That's typically where many organizations start. Okay, so quickly, I want to jump here. I have a fantastic local example, regional example from Caribbean Airlines, CAL. And here you see applications that CAL migrated to cloud, highlighted here to Azure, specifically Microsoft's cloud, flight status, maintenance and engineering staff, pickup and drop off. Again, moving VMs from on-premise to Azure, okay? And here you see a fantastic statement from CIO Jeremy Mohammed at CAL in terms of the agility enabled by moving to cloud. Fantastic transformation story, fantastic beginning of that journey. Now, when you get to the next steps, re-platform, refactor, re-architect, again, driven by what I mentioned before. In this case, it's not technical debt because you're running on a cloud provider, but going to the next step does give you increased agility, does give you increased value in being able to quickly unlock various services to grow your lines of business with microservices, with containers. And so let's touch a bit on that, right? Re-platform, refactor, re-architect. This is where we have spent significant time investing in AI approaches to ultimately figure out how not only to do this, but the benefits that enterprises might see. So jumping to the next chart here, I will begin with re-platforming. So let's remember what this is. This is going from virtual machines to containers, okay? Or going from old container systems to Kubernetes, older container systems like Cloud Foundry, an older container system, Docker Swarm, an older container system. So here you see an example of a Fortune 50 insurance company where they were able to leverage this capability known as move to Kube, very intuitive in terms of what it means, move to Kubernetes, re-platforming their application, their mission critical application to a Kubernetes environment. And in this case, what does that mean? That means discovery of the existing files and artifacts associated with the current environment, taking those files, translating them into the artifacts of Kubernetes. Those familiar with Kubernetes will know concepts like operators and Helm charts and the like, and automating that process. So automation is a big part of this with AI. It's really AI-assisted automation in many ways, though there's no AI here, just to be clear. So this was announced at KubeCon. This is open source as part of what is known as Project Conveyor. We truly believe that in an approach to get more enterprises to embrace modernization and migration technologies requires a strong open community, and that's what Conveyor is. Move to Cube is part of that, launched at KubeCon a few weeks back and available for anyone to try. And again, the success story here of this Fortune 50, accelerating their re-platforming by 9x, reducing their clusters by 55%, so their overall cost of ownership goes down, and development was expedited here, taking 5 hours to build new environments versus 6 weeks. That's the 200x speed up that you see. So that's re-platforming. But again, re-platforming, while it gets you to containers, doesn't get you to microservices. Why are microservices important? Microservices are important because they decouple how various components of the application is interacting. It's not interacting with technology. It's interacting with business function, and you'll see a clear example of that. So I'll touch on that now. This is really the heart of the refactoring process. Piece of technology known as mono to micro, also intuitive, going from a monolith to a microservices organization, piece of software, excuse me, and launched at Think. Here's a publication in AAAI of this year, articulating some of the science behind what is done in refactoring as a whole. And just to show you a sample application on how this is done, this is an open source application known as DayTrader, and which showing 5 microservices after the refactoring process. Here, the approach is, this is an unsupervised machine learning model where we do runtime analysis on the application. The output of that feeds a hierarchical clustering model that ultimately groups objects that are closely related. In this case, it's market summary, trade management, account management. So you see here how microservices begin to directly couple with business function as opposed to a monolith where they're all clustered together. As part of that refactoring process, database access patterns, call volumes between parts of the application, business context, all of that is factored in. Now, this doesn't replace an architect. You still need the architect. And that's why I highlight here step 2 in terms of customization of the partitions that you see each of these nodes representing partitions of the microservice, whether it's market summary, trade management, account management. And that customization is feasible from an architect point of view to validate, okay, whether what has been suggested is actually accurate, is actually the right functionality for that particular piece of code. And then, of course, there's the generation of that code so that this new application can run, which is what you see in front of you. So we've not only launched this early Q1, but we tested this before launch. And here's a good example. This is this particular tool that I'm showing you is for Java-based workloads. We did some work with an automotive company, Fortune 1. They had an application, mission critical app, warranty app, upwards of 1 million lines of code. It was taking them, and they wanted to quickly refactor and move to cloud. It was taking them upwards of 1.5 years. And with Monitor Micro, they were able to reduce that to 4 weeks. So it's really more than 10x, but 10x here is a good roundabout number to summarize the reduction in time to get to a microservices architecture with 20 plus microservices. So this is the possibility in front of you. So not only do you, if you go through that whole modernization journey that I talked about a second ago, 6R analysis, lift and shift, the CAL example, which is fantastic, regional transformational, replatforming, again, taking baby steps, right? You're a CIO, these are mission critical apps. They bring in revenue for your organization. They cannot go down when you try to do a replatforming exercise, or the replatforming cannot be done in such a way where it affects it. Likewise, refactoring, which is even more complicated. Here we're seeing great traction with many FSS clients. I show you an automotive example as a representative example of a refactoring journey. So when we talk about transforming a traditional enterprise, starting at business process, like we showed at the beginning, customer care, supply chain automation, this gets into the application stack so that you can, quickly not only move your workloads to various clouds, but refactor them to unlock the value of clouds. Okay, so that's modernization. I'm touch on 2 more and pause when at the end to take questions. Touch on security. Security, obviously, always in the news. We're no stranger to security issues, particularly in North America, particularly in the US, and globally for sure, but certainly breaches and attacks are very high in the US. So here's an example, a few examples that I show. Marriott discloses another security breach. Another, right, by the way, not one. So this was the second article, over 5 million guests impacted. I'm sure many, even if you're not in the security domain, you're familiar with WannaCry. And here's a nice snapshot from TechCrunch highlighting why WannaCry even came to be. SolarWinds, another huge one highlighted here. And very good one here as well. And this is just a snapshot. This snapshot, if I gave this talk a week from now, this snapshot would change. If I gave it 6 years from now, this snapshot would change. So there's no shortage of this. One of the key issues with security, right, is the whole notion of vulnerabilities. Human-introduced vulnerabilities that come about. Of course, patches have to be developed for those vulnerabilities. And there's a massive organization that tracks this, right? So National Vulnerability Database, NVD, captures all of these vulnerabilities. The National Institute of Standards has a vulnerability scoring system known as CVSS. Okay, and what I show in front of you are some of the challenges with that. There are over 140,000 vulnerabilities, huge. That's not trivial. Okay, There's a data breach study that we did 2 years back that revealed the cost of 11 cloud misconfigurations cost organizations upward of 57 billion. And that's just remarkable. It's practically 10 misconfigurations costing 57 billion. And then when you look at this data snapshot in front of you, this is data ranking vulnerabilities and the CVSS score based on criticality. And CVSS does that based on how severe it is, okay? One interesting thing, if you zoom into this, you see these two highlighted here, right? This is number 8, this is number 9. What's number 8 has a threat score computed based on how many times it has been exploited, as well as 2 other factors. I'll touch on that in a second, of 86.4. This one, 39.8, exploited, is the most exploited in this list, but it's ranked number 9. So as a CISO, as a security focal, if you had this in front of you, you would start at number 2 or number 3 and work your way down. You wouldn't start at 8 or 9, but you see how this becomes a challenge. It's a manually driven process, number 1. But number 2, the ranking you're getting from the NIST scoring, useful, but it doesn't give you the scoring from the perspective of a hacker. And that's really what's critical here. From a hacker point of view, there's clearly a different ranking you would come up with if you can somehow figure out how to programmatically do this. And organizations were doing this manually, but we embarked on doing this programmatically. And I want to touch on this now for the one demo that I have for just 30 seconds.
X-Force Red is unique within the IBM security portfolio. The X-Force Red portal is IBM's hacker-built collaboration and communication platform. As part of X-Force Red's vulnerability management services, the portal can provide a unified view of clients' highest risk networks, vulnerabilities exposing assets inside those networks, and the associated exploits. It also can show a prioritized risk-based view of which vulnerabilities it recommends clients fix first, so they can easily determine where to focus their time and resources. X-Force Red's hackers built the portal to provide clients one place to view their vulnerability data from the eyes of an attacker. The portal provides engaging visuals designed to allow security teams.
Okay, it goes on for 2 minutes, but that's the essence of what I wanted you to hear. So if I can do exactly what this shows, and the URL is available below, this would be great, because as a CISO, as a security focal, I can prioritize which ones I respond to, and I can do so programmatically in such a way that I safeguard my organization from security attacks. So let's take a look on the next chart on how this is done. So as one representative example. So here you see in front of you 2 vulnerability descriptions in NVD, National Vulnerability Database. The one on the left is actually WannaCry ransomware, which really had a tremendous impact and continues to have a tremendous impact on many systems. And the one on the right actually isn't exploitable at all. And you notice the CVSS score, right? They're quite close, 8.1 versus 7.5. So from a security focal point of view, you might have, done them roughly at the same time. Because this is 8.1 and this is 7.5, maybe you would have done this one first. But really, you shouldn't even be looking at the one on the right at all. When you look at the descriptions, right, in front of you here, what we've essentially done is to train a machine learning model with various labels in a supervised approach. And with the supervised approach, using a variety of classification techniques, ultimately inference on what is known as the utility, which is the weaponization potential of the vulnerability. So here you see a categorization of that utility. If it's 0, it's not really useful to a hacker. If it's 1, it can create these so-called attack chains, okay, so that you begin to take down a series of systems. And then 2, actions and objectives. Whatever the objective of that hacker was, they achieve it. That's what the score of 2 means. And so the gas pipeline issue in the news recently is a good example of one that has that potential. And ransomware certainly does as well, WannaCry ransomware. And so this is the approach with both classification, there's an active learning approach, and then explainable AI is also provided to help provide explanation on, well, why did we suggest that you should be taking a look at this particular vulnerability as opposed to another, and prioritize responding to this one. So I want to show you one example here of what this has enabled for a client. Again, not only do you enable complete coverage of the entire vulnerability space, again, there are 140,000 plus vulnerabilities in the wild. So as a CISO, you can't do this manually and have 100% coverage. So our estimates with the clients that we have put this at 5%. That goes to 100% with this programmatic approach. And for a food service wholesaler, we were able to reduce the time for that wholesaler to respond and prioritize the various vulnerabilities to which they should respond by a factor of 10x. And you can think of this food service wholesaler for those in the region as an equivalent of PriceMart, for example. The table on the right shows you exactly what happens, and that's, of course, what you saw depicted in the video as well. So that's security, just touching on a few examples. And you can imagine, getting back to cloud architectures, you can imagine with a CI/CD pipeline, you can imagine with containers, microservices architecture, you can see how someone would benefit tremendously by being able to prioritize not only the vulnerabilities at runtime, but also those at build time. I'm going to quickly fix my lighting. Apologies. Okay, very good. So last but not least, I want to touch on keeping applications up, so-called incident management, AI ops. And like I said at the beginning, this is an area that perhaps is the most advanced, so to speak, in terms of the application of AI to software artifacts. Many have been doing this for some years. But it's interesting when you look at this field, what is emerging as critical so that you can get to a preemptive state, a proactive state. How can you predict when something may go down so that you avoid having an outage entirely? So just like I did with the other sections, I want to touch on incident management in the news. Clearly, this happens to everyone, including us, right? So, you know, no particular reason. I just pulled some relevant ones that really made the news within the past couple of years. This one from Azure related to a change in their authentication system. This one from Facebook a couple of years back, also a server configuration change. This was an interesting one. I remember it well. It was the first day of work and Slack would not work. Slack is a for those not familiar, a communications tool used by many enterprises and also used in the application that I will showcase in a minute for AI ops. And the reason I actually additionally chose these two is the whole notion of change. It turns out that when you talk about IT operation challenges, one of the biggest challenges you see here from this APM Digest article, human error, #1 cause of outages, IT outages in the US and Canada. Here's the cost. Average cost, 100,000 per hour. Average cost of a critical application failure can be anywhere from $500,000 to $1 million. So quite significant in terms of the financial impact. And you know, nothing is as upsetting to you know, a CIO who receives the calls related to, okay, we have an outage. I guarantee you it's a very hot moment as you try to remedy that. So change risk is a huge area. This is a Gartner chart from 2019. As far as priorities that they put on the AI ops spectrum. So I want to highlight this one. I'll also touch on another one quickly, but I want to touch on the whole notion of how can you get in front of issues, outages caused by change, which again is a human issue. And as you see here, the #1 issue related to IT outages in the US and Canada. So the approach we took here is the following. Like I said, many companies have been doing this. There's the likes of ServiceNow. More recently, there's the likes of Mooksoft, a huge proliferation of companies, Big Panda, Datadog, and so on. We have been in the space for many, many years. But one of the things that became obvious was the following. Just like clouds are run from the evolution of what I would call the sysadmin role to a site reliability engineering role, this is how traditional enterprises, as they migrate workloads to cloud, aim to keep workloads up. It's not sufficient for you to look at things in a disjointed fashion with multiple dashboards, okay? And the sysadmin, the SRE, is not able to speak to the storage expert in the same medium. You're sending emails, you're slacking, you're using Slack messages, or you're using WhatsApp, what have you, right? Very uncoordinated, and a fragmented type of approach to triaging IT issues. And so an approach we took on, which is actually somewhat similar to what MOOCsoft does, and others are going in a similar direction. Can you create an environment where you ingest all of that data from your cloud instrumentation, from your application instrumentation, pull that into that environment, and of course, having models run on that data, whether it's application logs, whether it's events, whether it's metrics, what have you, runtime traces, and with the output of those algorithms, able to make reasonable conclusions and invite anyone to that Slack channel if you're using Slack like we do to ultimately address and triage those issues. And so here's a publication that I highlight as well in this year's, in this year's International Conference on Software Engineering on the approaches that we take, whether it's on incident problem management or change and release management. So again, the idea being, if I can correlate alerts, I can get to the blast radius using log analysis data and the like. I can quickly do my diagnosis with the ingestion of all that data, models on that data, invite who I need to triage and resolve and drive for changes. No different in a change context, okay? If there are changes that have caused issues, or if I want to figure out if a change may cause an issue, this is what I can do. So the product is shown here. I won't spend a ton of time on it. It shows you the lay of the land, what it aims to do. Acquisitions have happened here as well to complement the features. Instana being one, Turbonomic being another from a cost and asset management standpoint. It works with many technology partners, including ServiceNow, who many use for ticketing management. And of course, like I said, communications done through Slack, running on all clouds, much like the other applications do as well on top of our platform. And so let's get into how this actually works from an AI point of view. So if I make a change, okay, or I want to make a change, right? On the left, what you see here is a current proposed change, okay, for a particular service. On the right, you see a failed change, meaning not the change caused an incident, but the change was not successful, okay? I want to be able to compare the two. If I can learn, that's what machine learning, that's what AI is all about. I want to learn from those experiences so that I don't submit another failed change. Worse yet, if this change actually caused an issue, I don't want to submit this and have it approved in such a way that it triggers another issue. And this is exactly what this does. So in terms of the approach, you see here highlighted text. This is a tokenization mechanism, NLP technique. We extract tokens and we vectorize those tokens with approach known as TF-IDF, right? Term frequency, independent domain frequency, document frequency. And so with those vectors, we then apply a binary classifier, and that binary classifier allows us to, in this model training, get a sense of where we are, and then we can subsequently inference with a running example during test, as is the one on the left. And so this change was closed, okay, and you see here the risk of this change being, medium to high, 72%. So it tells the SRE, okay, that this may not be useful to pursue, right, because it was unsuccessful previously and so on. And in terms of the actual accuracy or the prediction accuracy, this actually comes from at runtime redacting each of the various tokens to figure out which token had the most significant contribution. So again, AI being applied to the language of machines. Okay, in this particular case, these are tickets that are put into ServiceNow, and so there's the element of human composition. So it's a mix really of human and machine language to ultimately allow you to assess what changes are risky. And you can do this in a reactive way as well for changes that cause an incident. So I want to show you an internal example, right? Whatever the expression is, eat your own food, drink your own champagne, right? I showed you the Watson services before with CVS Health, with Bradesco. We have applied this internally. These are 12 services across the entire Watson suite running across 8 environments, close to 1,000 changes a month, all right? Here you see the F1 measure, which gives you an indication of how well that algorithm is performing. And here's a notification from the site reliability engineering manager on how well this is performing for that organization for 6 months. So this is a feature in the product, and we continue to test this. Banks turn out to be a huge tractor, so to speak, for this feature as part of the product. So we'll see how that proceeds. And last but not least, I'll touch on an additional part of what the product does in terms of a predictive notion. If you're collecting logs, okay, application logs from your applications as they run, which is time series data for metrics, time series data for different types of metrics and the like. Typically, from a human point of view, you can look at these one by one, but we employ a multivariate approach, which means you take a linear combination of these metrics, of these time series data. And with that linear combination, we apply a multidimensional reduction approach shown here. And here you see a couple of examples with different clients, a large Asian bank detecting an incident 6 hours prior to occurrence. Here's one that's an hour before. Each of these timestamps represents anomalous logs as classified by the multivariate analysis PCA approach, principal component analysis approach, allowing us to detect this one a little bit over an hour or so before it actually occurred. So a useful capability as well across all range of apps. So this really summarizes what I wanted to take you through, just to wrap up, right? Took you through, baseline view on what Cloud 101, so to speak, is AI, the disruptive trends, and how you smash those two together. Applying AI to cloud, the notion of applying AI to code, which is what Project Codenet is all about. This is open. All developers on the call, by all means, if this is an area that excites you, encourage you to check out this GitHub link. You'll also see in there the paper we're working on and how this data set compares to past data sets. In terms of the modernization work, there's an open conveyor community here as well. I encourage you to check that out. If you're in the CIO team of any organization, banking, telecom, retail, what have you in the region, or anywhere else in the world looking at this, I encourage you to take a look at the conveyor community. And then from a product and SaaS point of view, these are the products covering modernization, security and compliance, and incident management that I just covered. But before I stop, just one thing I want to say additionally. I would be remiss if I didn't acknowledge this is a UE Health Forum. Again, I appreciate UE inviting me to deliver this lecture. As Professor Copeland mentioned, we have a relationship with UE at IBM Research. And I really want to highlight these fantastic scholars. I think some of them might even be on tonight. It gives me, a tremendous pride to see their faces here. They've done amazing work. They, while at IBM Research, they've gone on, of course, to do fantastic things. You see where they're all affiliated, and some are also finishing up at school and so on. So I want to congratulate them. I want to acknowledge Professor Akash Paransing, Professor Malalu, Professor Copeland, all of whom helped to make this feasible. On the IBM side, Kevin Fauchon, General Manager, IBM Caribbean, and his team, Pat Tomlinson, retired Selma Mohan, and Simon Aki as well, who may also be on. So with that, I will conclude, and I thank you very much.
Thank you very much, Dr. Fuller. Thank you very much, Dr. Fuller. Your presentation was quite interesting. We focus a lot on application, the benefits, and of course, the operational challenges and the predictive logs. I'd like you to make sure you place your questions in the chat, and the question and answer session will be moderated by Dr. Pedro Mohammed, who is a lecturer in computer science at the Department of Computer and Information Technology at UE. Dr. Mohammed?
Hi, good evening, everyone. So welcome to the question and answer session. You now have a chance to connect directly with Dr. Fuller and ask anything that inspired you during this presentation or maybe confused you. And we can get an interactive discussion going on the topic tonight. So I noticed a couple questions have already been posted in the chat. So thank you for getting that started, Sachin and Catherine. So I will kick off with some of their questions, Dr. Fuller. So the first one comes from Sachin. His question is, your analogy of cloud being used as a utility would suggest that it should also be regulated as one. How do you feel about that?
Yeah, it's a great question. But I do believe that there should be an element of regulation in there as well. If cloud is to truly be used as a utility, which is certainly what we're seeing happening today beyond SaaS enterprises and traditional enterprises as well, there's an element of that. Now, like everything else, when you talk about regulations, right, there's always this battle between regulatory versus so-called exploration and entrepreneurship. To be clear, right, many regulations across Europe, North America, Asia, the region, Caribbean do apply. So whether it's for healthcare data, HIPAA applies. It's for cloud applications. In terms of financials, there's in North America, FFIEC, PCI for credit card-based transactions and so on. Recently, GDPR over a year ago or so from Europe. So the regulations are applied in the context of compliance, ensuring that you certainly comply with whatever compliance standards exist for that region.
Yeah, it's so interesting when you mention it as a utility. It's not something you would immediately think of, you know, okay, I have to pay my electric bill, my water bill, whatever other physical things now, and well, internet bill, of course. Now, a cloud bill is something that might not be so novel anymore. So in terms of some of the tools that you mentioned, so these are AI-based tools primarily, things such as Watson Assistant, which is an AI-powered virtual agent, things like Watson Discovery, which powers intelligent search and text analytics, and then IBM Knowledge Suite, which can be used to annotate documents and allow businesses to pull out relevant information. The question is, what might be some of the primary concerns practitioners might face in leveraging some of these tools?
Yeah, fantastic question, and it's one we typically get when I say we, anyone presenting on AI, irrespective of where your affiliation might reside. So, certainly from an IBM standpoint, our notion of AI as a augmenter to the practitioner and upskilling the practitioner is not only our belief, but what we put into practice. So in any of those examples that I showed before, we don't expect Watson AI Ops to replace SREs. We don't expect X-Force Red to replace security focal CISOs. We don't expect Monitor Micro and our other modernization tools to replace architects. They augment each of those practitioners. And in the process, because you reduce time, just imagine being that security focal, right? Spending so much time looking at vulnerabilities, figuring out which one to patch. Now you have a programmatic way to respond. Fantastic. And now you can upskill and do additional things that might be needed from you from an organizational standpoint. So certainly when you talk about repetitive tasks, right, the notion of replacement becomes even more heavy. In the context of what I showed here, we believe it upskills the practitioner and serves to augment what the practitioner does.
Now, they're getting braver, so I'm seeing the questions coming in, which is excellent. So a very common question with AI is the bias, the issue with data being pulled from certain sectors that would naturally have leanings towards certain trends that you might experience in other settings. So Sachin asks, again, what has IBM been doing to reduce that bias where that model behavior would then be skewed?
Fantastic question. So 2 years ago, we released Watson OpenScale, and that's the job of Watson OpenScale from a bias detection point of view. We view this as a critical area. It's a hot area for us in IBM research as well to continue to advance the innovations that we put into that service. It's one of the 12 services running on not only our cloud, but available on other clouds as well. And we, when you talk about, there's so many different applications where you use AI where bias detection is critical. But in the context of what I showed here today, you can easily see how a hacker could take advantage of manipulating training data to ultimately impact adversely the intended output of each of these. So bias detection only becomes more prominent. Unfortunately, there are technology savvy characters who know how to take advantage of technology for the wrong means. And so in terms of the direct response to the question, OpenScale is our answer to that. We launched 2 years ago, and we continue to do more work to embellish and provide innovation to it.
Open source is pretty much the equalizing factor in so many things. In terms of equalization, Marilyn asks, how far behind are CARICOM countries in terms of cloud technology? Generally speaking, how far ahead, so to speak?
Yeah, very good question. So, and as you would notice, right, I took some regional examples and I extended, I took some latitude in extending the definition of regional, including what's being done in Latin America as well. I think the Cal example is a fantastic example, right? I know there are many other organizations taking that typical entry point in terms of business process and looking at other ways of leveraging cloud. I will also say there's a conference known as Tech Beach. And at Tech Beach, I was pleased to meet some of those individuals who host and organizers for Tech Beach, may even be on. I was very pleased to meet many startups who were leveraging various clouds operating in the region. So I don't think we will have a challenge in CARICOM countries from a SaaS point of view, born on the cloud. This is what you do today. You're a hotshot, you're coming out of school, you know computer science quite well. You get together with some friends, you swipe your credit card, you lease real estate, you put your business plan together, you evolve, you test it. Hopefully you do well. And if not, you pivot, you adjust, you react. It's largely a bigger challenge for the reasons I went through, which is why it's a hot area for us as a company for traditional enterprises. But again, we have good examples as well in Cal. And I think the pandemic in some ways is an accelerator, an impetus, right? In order to take, facilitate, leverage what is in front of you. Again, going back to my utility example or description, your core business, if you're a bank, your core business is banking. If you're a telecom company, your core business is telecommunications, which is why the notion of cloud as a utility is one that I typically use.
So you kind of touched on the idea of Caribbean developers, coming together and building from there. So we have a question from Lorcan where he asks, in the Caribbean, we tend to have a low level of software engineering capabilities. Well, again, that's one perspective. His question is, we are very creative people in the Caribbean, but we're not seeing much traction in terms of that local businesses investing in these types of technologies and encouraging, I guess, young students and entrepreneurs into software development. His question is, well, what can we do to sort of kickstart this sort of thing? Because IBM is a very large company, very successful. So you're seen as a superhero in the sense of the grand scheme of things. How can we, so to speak, in the Caribbean, follow that path?
Yeah, so it's interesting, right? And I was just passing Vincent's Ramuta's comment as well as you read that question. From the 14 or so individuals, and I interviewed many others from UE, and I've met many others as well, not only the 14 individuals who have interned with us. I think there's a wealth of talent, okay, across the region from a software development point of view. So respectfully, of course, I disagree with the notion that we don't have the talent. I think we do when I look at these 14 individuals and the many others whom I've had the privilege of meeting. That's number one. Number two, I think, again, I want to come back to the point. I want to underscore the point, right? You saw many of those individuals, some are at Cal, some are at Republic Bank, what have you. You have the opportunity with good ideas to be an entrepreneur. You don't have to buy servers, buy operating systems, licenses for those, licenses for middleware, and then build out your application and maintain your application stack, right? Which was the old approach. You can, of course, you need some investment money. So that clearly is a challenge depending on socioeconomics and the like. But again, I go back to the Tech Beach program and also what they're doing there. I think it's fantastic because we have the opportunity. Again, if you're a hotshot, I see these great ideas from many of these individuals. Pursue those ideas. Obviously, traditional enterprises will move. It's not just a CARICOM statement. That 20% move to cloud, that wasn't a CARICOM statement. That was a global statement. This is what we see across quote unquote developed countries, whether it's North America, whether it's Europe, whether it's Asia. There had been a general reluctance for traditional enterprises for a variety of reasons to move to cloud, and therefore the whole software uptick, so to speak, in terms of software engineers would have tended to be different versus for SaaS born on the cloud enterprises. But you have that opportunity. You have that opportunity in front of you. as talented individuals graduating from UE. There's online courses as well available today. So different, right? You can do a Coursera course, become certified, as some of you have done already, and others are pursuing, and pursue that passion. I would strongly encourage you, never let anything inhibit whatever passion you might have and whatever goals you have in front of you.
I fully agree with you in terms of the search of talent, because as a lecturer in the DCIT at UWI, we see some fantastic student projects, research projects, as well as undergraduate final years. So many of the technologies that you were mentioning, our students use to. For instance, there are things such as BERT. This is a very popular natural language model out that's doing some truly impressive things. Just a couple months ago, some students were able to implement that with some limited resources here in the Caribbean and produce some really good results. So imagine what can happen when we get even more support from industry. So I would probably throw this out to those of you who are in industry, come and find us with internships and let us, build that synergy so that the things that we teach, you get to benefit from, and the things that you need, we get to teach. So it's kind of like cyclic. So we had a very interesting question from Jean-Pierre a little bit earlier. How does mobile and edge computing impact the adoption and implementation of AI for code?
Yeah, fantastic question. And it's interesting because recently internally I've been expanding my role encompassing edge as well. I'm no edge expert, but certainly learning a lot. And as I learn more about edge, one of the biggest challenges you have, right, when you talk about connected vehicles, connected operations, or imagine like a Starbucks, a Wendy's, what have you, right? KFC, right? You have IT running at your centralized location, you have IT running on cloud, and now you have IT running at branch offices. As you go to smaller and smaller devices, you have disconnected operations and the like. The whole management tasks that I went through here become even more challenging in my view because of the infrastructure and how that infrastructure varies going from edge to cloud to traditional. And on top of that, what it means to therefore find solutions from an AI point of view. So I actually think it will help to fuel even faster growth of Codenet. Codenet is already growing very quickly, just to be fair. But I think when I look at edge and I bring edge into that context, and of course, this is one of the fastest growing areas, I think it serves as a hotbed for what we can potentially do to help the challenges, again, that will surface in this context.
Fabulous answer. That AI for code project is so impressive. I don't know if people really appreciate the scale of being able to have a computer program another computer. We have trouble with natural language, much less if we try to implement our thoughts in a machine language, which was translated from a human language. So it's really, really, really impressive, that entire project. So Javon asks from Trinidad, where do you think the AI for code project might end up in the future? So moving from monolith to a microservices type setting is amazing, but he's just curious, what would your perspective be for where it might eventually go? So he suggests maybe security coding or something like that.
Security coding, language translation. I can easily see, assuming we make the right set of breakthroughs and you have equivalent code performance, right, taking dated languages and performing translation, much in the way that there was an article I read, I forgot, I'm forgetting the expression used, or this tool that is used for learning a language in a few weeks, right? But anyway, it coined this technology in that way, or this data set in that way, right? I can easily see many individuals subscribing to, okay, great, I can translate my PL1, I can translate my C++, I can translate this into Python, right? Which is of course the hot language of today. To me, that's a huge one. Security is a big one as well, for sure. the sky is the limit. You know, I can't possibly sit here and predict everything that's going to happen from Codenet. I think if you ask the people who launched ImageNet when it was 3 million images, it would have been difficult for them to entertain where vision has gotten to, especially in the context of social media, right? So I look forward to being startled and amazed by what the globe will produce with Codenet.
So we have a kind of overlap with questions from, I hope I pronounce this right, Tahaka from Trinidad, and Daniel as well. So they ask, what area do you think provides the biggest opportunities for, or the best use cases in the Caribbean for using AI and cloud-based applications? If you had to maybe, condense in a nutshell.
Yeah, so if you go business process up, right, there's a wealth of opportunity no matter what, and certainly for the region as well, right? So customer care is an easy one, right? Everyone needs the ability to automate how you respond in an intelligent way that gets you what you need. That's an easy one. Supply chain as well. Analytics, yes, I can see that being useful to some industries and so on. As you go from, we have a heavy regionally, right? Obviously, heavy banking sector, FSS sector, okay, agricultural sector, tourism sector. You can see a wealth of intelligence being put across all of those sectors. Now, when you get to the app level, right, which was the heart of what I spoke of today, I do believe that the faster our traditional enterprises can embrace the transformation discussed here today to get them to a point of using the cloud as a utility and benefiting from being able to accelerate their businesses, I think we'll hit a holy grail. So that's pervasive, irrespective of industry. But I think the question was more on the business process up. I think there's a whole wealth of stuff that is there to be done across tourism, agriculture, FSS, you name it, that only serves to benefit the region and continue to make the region attractive, not only from a tourist destination point of view, which is great. Who doesn't like warm weather with beaches, but in terms of a hotbed for innovation, no different from small places like Singapore and the like.
I think we're running fairly okay on time. I probably have 2 more questions we can squeeze in. But Derek asks a very interesting question. Do you think there is a need for a Caribbean policy response to standardization of these cloud service transformations? So what I think he's getting at is, if you're using a utility, that implies some sort of standardization or agreement or consensus on what is provided, cost, and so on. So I think he's trying to ask, for this to be taken up in the Caribbean, where we have enterprises with limited budgets, what are your thoughts on some sort of policy?
Yeah, probably getting out of my comfort zone. It's a good question, and I'm not shying away from it. But certainly something for heads of government, the equivalent of a science and technology director or minister of science and technology across the various regions to be looking at. But I do think it, if not the pandemic, if not the COVID pandemic, then what? Right? I can't emphasize enough how transformational this has been across quote unquote developed nations, whether it's distance learning, whether it's food delivery, whether it's supermarket delivery, whether it's meetings, conversations, business meetings, deal closures, all done remotely, okay, through technology, through cloud providers, okay, not traditional enterprises, okay, and so allowing you as a traditional enterprise to focus on your business. We have to embrace the utility, or we risk being left behind.
For sure. Last question here from Lindell. Can you provide a rough estimate on what sort of time frame that a move to a cloud-first approach might buy some entrepreneur who wants to take that leap, especially if they're using some sort of AI technology within that process?
Yeah, a cloud-first approach gets you there super quick, right? You come up with your design, Of course, you go through the necessary processes as it relates to the implementation of your design, and of course testing that design, and then surfacing that in pilots and getting feedback from your clients, and then ultimately growing adoption and getting to scale, or pivoting. That's typically what happens here. It's a very much iterative, reactive process on fast 2 to 3 week cycles. Nothing like it that certainly didn't exist before the advent of containers, microservices, and DevOps. And so the time is the least possible time as compared to a standard approach, right? A standard approach, very dated, doesn't, it actually wouldn't, any new enterprise pursuing quote unquote, the old approach would not be able to compete. Whatever good idea you think you have right now, yes, probably a great idea. Someone else has a similar idea, and that's why the proliferation of technologies and software is significant. The ecosystem is what eventually wins. So open becomes a big part of that as well, right? Open source. So time to value is key. Cloud first approach is the winner. No debate in my mind about that. And you're speaking to someone, you heard the introduction, A-levels, physics, chemistry, math, further math, PhD physics with some computer science in there. Always had a very hardware approach, grew in the software space. No debate in my mind how this should be done.
Okay, just two last questions quickly. One from Brendan, more of a technical one. What are your thoughts on the FaaS, so function as a service, more granular approach,
Oh, wow.
serverless paradigm? And how would Codenet affect something like that?
It's a fabulous question, and that's the next paradigm. I didn't touch on serverless here, right? So quickly speaking, right, whatever is under the covers, so much you have to think about, even with microservices, containers, and DevOps in terms of config, right, as a software developer, right? Serverless takes away all of those issues, compliance issues, etc. So it's remarkable, right? Of course, Amazon launched Lambda, there's functions on our side. And I think, well, serverless is still very early. It's sort of like figuring out how to colonize Mars and make money, in my view. But in terms of its impact on Codenet, and maybe I'm not following the question clearly, but that's the future paradigm for cloud. So if containers is the current paradigm, right, that's the future paradigm for cloud without question. When it becomes a reality is debatable. I think you'll first see SaaS get there, okay? And maybe this is the question. So can you now do, say, replatforming to serverless? Okay, so we're looking at that. Can you now, instead of going from VMs to containers, go from VMs to serverless? Can you, and as part of that, can you refactor as well? So a remarkable question. I love that it was asked, and I'm glad you're thinking about it, because if you're in that space, just continue to feed your passion, because it's only going to grow.
Last question to close off. I like this question. So Lorcan says, user education, process change, data conversion, these are all people-intensive activities. And usually people are the barriers to, adoption of novel things, yeah? How can AI, which is scary in its own way, that's just my piece of it, help people get over that, that inhibition?
Yeah, that's a tough one, especially when you talk about education. We tried and it didn't work, just to be clear, right? It's a tough space. And we see the benefits in some places. We had a pilot in West Africa that worked out well. But in terms of en masse, how does this work? Listen, I think, I remember, my grandmother, may her soul rest in peace. I remember her not wanting to wear her seatbelt when she got into my car as a teenager, right? And I would say, come on, you have to. No, why? She remembered a time when there was no seatbelts, right? That's why. So this is always, you see this with vaccinations now, which I don't even want to get into, given that we have limited time. There are people who don't subscribe to the notion of vaccinating. Okay, fair enough. Technology embracing technology for advancement, it can be a tough thing when there's a whole cultural notion applied to it as well. That said, though, I think, and there is momentum, just to be clear, in my view. I don't live home, but I have enough contacts and relationships with folks at home. I do believe there's momentum. I think if that momentum continues to grow, I think those people will eventually come on board, right? No different from my grandmother finally wearing her seatbelt. Hopefully, this is what we see going forward.
For sure, that uncanny valley, I think that's probably what scares people when you see technology becoming so close to how we behave. You know, it's a bit eerie and weird, but now we have these softer things that are slipping in, voice assistants, search. It's so pervasive, they're not noticing the AI. So maybe that's something that might happen there. All right, so thank you so much everyone for your questions. Really, really stimulating discussion. And I hope you guys continue to read and again, reach out to the open committee for access to the recordings and so on.
Thank you, Dr. Mohammed.
Thank you,
Thank you.
Dr. Mohammed. Thank you very much, Dr. Mohammed. As you agreed, there's quite an array of questions, very interesting questions. And thank you, Dr. Fuller, for your response, and Dr. Mohammed. For closing remarks, I'd like to introduce you to Mr. Nai Faranan, who is the head of optometry of the Department of Clinical Surgical Sciences, and who is also a member of the Open Lecture Committee. Nai?
Thank you so much. On behalf of the chair, Prof. Badri, and my colleague, Dr. Mohammed, and my other colleagues on the Open Lecture Committee, we would like to thank Dr. Fuller for a very relevant and fascinating lecture. And of course, this can be seen by the number of questions. We didn't even have an opportunity to go through all of them, Dr. Fuller, so that just shows the interest in your information. And 1 hour ago, I didn't know there was 3 different types of different AI, and now I know there's narrow, broad, and general, so that was fascinating. And also the different success and uses of artificial intelligence. And, you know, we had some local examples of Caribbean Airlines, and that was very worthwhile hearing. Every day you see the security issues. Ireland had a security issue there that the Department of Health records were hacked. So security issues was a very relevant team, and incident management and IT operations. And then finishing off with the IBM Watson program, which is got a lot of potential, as you said, Dr. Fuller. And then at the very end, it was extremely heartwarming as a UWI alumni myself to see all those pictures of the UWI alumni who are working in IBM. It was a very, very nice touch. Thank you, Dr. Fuller. We'd also like to thank the family of Dr. Fuller who signed in, and his friends. There was many people from the different regions, Guyana, Jamaica. We had people from Atlanta and other parts of the USA. And Dr. Fuller, they all give you good wishes and warm wishes on that good lecture. We'd like to thank the Pro Vice Chancellor and the Principal, Professor Copeland, for his introduction to Dr. Fuller. And we'd like to thank all our colleagues in the university who came out today. We'd like to thank the business community who also participated, because again, a very relevant subject, as Dr. Fuller said. We'd like to thank the members of the media, and we'd like to thank everybody that tuned in tonight to listen to this wonderful lecture by Dr. Fuller. We'd like to tell you all to stay safe and have a wonderful night, and we wish you the best of luck. Thank you, colleagues. Thank you, Dr. Fuller. Thank you.